Hello friends, so welcome to our channel. In this session we are going to learn about the time complexity. The time complexity we represent in big O notation. So measuring time complexity using big O notation. So what is big O notation? So big O notation is used to measure how running time for your program so grow as input size grows. Here we are going to use the big O notation to determine the running time of your program. So based on the input size. For example, the input size is n. Then, so what is the time? If you increase the n value, then also you are going to measure the time here. Now, so based on the n value, the t also increasing. Let us discuss with one example. So consider this program. Here we read one n value. Now we are going to store the numbers from 1 to n in a list. It's a simple program. So for this, we are going to give the n value. So based on this input, the time will be vary. First, we execute the program. So this is the program here. We take one n value. Now, in this list L, I want to store all the numbers from 1 to n. Okay, here, so what is big O notation? So big O notation we are going to use to measure the time complexity. So based on the n value. So this is the n value we are going to read from the keyboard. Let us execute this. Observe here, I am giving n equals to 10,000. N equals to 10,000. If I press enter, so this is the time. How I measure the time? By using time module. So this is the T1 and T2. So before for loop, I find the time. So after for loop, I find the time. To know the execution time, T2 minus T1. Okay. So this is the time here. Now again I execute the program. Now I give input as 1 lakh. Now you observe the time. So previously it takes 0.0010. Now it takes 0.0180. The time is increased when the n value is increased. Now again we are going to execute one more time. Here I give 3 lakhs. The n value is 3 lakhs. Okay, you observe 0.01 when I give n equals to 1 lakh. Here when I give the 3, the time equals to 0.06. Again we execute one more time. Here I give 10 lakhs. Now 0.384. Okay, so now what we understand, if we increase the n value, it takes more time to execute. We understand that. If the n value is increasing, if the n value is increasing, the time is also increasing. That we represent like this. If the n value is increased, the time increases. Okay, here we understand that the program will execute on different configuration systems. Here I execute the program in i5 system, so i5 processor system. If I execute the same program by using the i7, maybe the time will be decreased. Maybe I execute the same program in i3 processor, then the time will be increased. Okay, so now this is not the correct way to measure the time complexity of a program. So we need one mathematical model to represent this time complexity. That is a big O notation. So big O notation is a mathematical representation of time complexity. Here we present the time complexity in mathematical model. So the linear function for this program is time equals to a into n plus b. In previous program, so how many for loops we are using? One for loop. So now in this I process this for loop from 1 to n. So here a into n plus b. A represents number of instructions we are using in for loop, and b plus b means the remaining instructions. Here we are going to consider only highest value. So now a into n plus b, the highest value is a into n. Now the time equals to a into n. Now remove the constant here. The a value is the constant. So that we represent the time of this program is big O of n here. Now what is the time complexity of previous program? The time complexity is big O of n. Now simply you understand that in your program you have one for loop, and that for loop we process up to 1 to n. Then the time complexity is big O of n here. So consider this program. In this program we don't have any for loops. So now what is the time complexity here? The linear function for the program is time equals to a here. So remove the constant, then the time becomes big O of 1. Now here we understand that if in your program there is no looping, then the complexity of your program is always big O of 1 here. So this is the program to find the prime numbers and store all the prime numbers in a list L here. Now, so based on our previous experience, you understand that if there is one for loop and we process up to n, that is big O of n. If there is no for loop, then the time complexity is big O of 1. In this program, if we observe that we are using one for loop in another for loop. Here we are going to process up to n value. Whenever the I value becomes n, then also here also we are going to process up to n. Okay, that means here we are using nested for loop. Now what is the time complexity for this? So this is the linear function for the program is a into n square plus b. So one for loop, then a into n plus b. If there is no for loop, then a. If there is nested for loops, then we represent as a into n square plus b. This is the time. So consider only highest value. So remove this b, a into n square, and remove the constant, remove a. What's the time complexity now? So big O of n square here. So you understand that. So b and a are the instructions. In a constant time, we execute these instructions. So we remove a and b. So based on the n value only, we are going to measure the time complexity. Now consider this program. So how many for loops we have? So this is the for loop in another for loop. So it is big O of n square. So this is big O of n square. So there is another for loop in same program. So big O of n here. So big O of n here. The linear function for the program is time equals to a into n square plus b into n plus c here. So consider the highest value. Always you consider the highest value. So why we discuss in few moments. Now if you consider the only highest value, then it becomes a into n square. Remove the constant. Now what is the time complexity for this program? So big O of n square. Now we see, so why we ignore b into n here? So big O refers only large value of n. So why? If you have a linear function like 7 into n square plus 9 into n plus 95. So these are the 95 means the remaining instructions outside these for loops. N represents, in for loop you write 9 instructions, execute 9 into n times. So in n square, in one for loop you write 7 instructions that execute 7 into n square. Okay, you don't bother about these constants. When the value of n is very large, then we are going to ignore b into n plus c. Why? Take one example, n equals to 1000. Now time equals to 7 into 1000 square plus 9 into 1000 plus 95. Now what is 1000 square here? 1 lakh. 1 lakh into 7, 7 lakh thousands plus 9 into 1000, 9095. Here you compare this. So 7000 compare with 9095. So when comparing to these, we are going to consider only 7000. That's why big O refers only large value of n here. I hope you all are understand. So big O notation. So how we are going to measure the time complexity? So based on big O notation.